So, good afternoon, everyone. I'm Claudio Pompilio, and I'm a PhD student at the University of L'Aquila, Italy. And together with my colleague, Alexander Perucci, I'm going to give this talk about CHOReVOLUTION Studio. This talk is on how to deploy and run services in a distributed way. In this talk, I will focus on the development process supported by CHOReVOLUTION Studio. So, the work reported in this talk is being carried out as part of an European H2020 project called CHOReVOLUTION. That is a follow-up of an European FP7 project called Choreos. It started in January 2015 and will end in January 2018. So this is the third year of the project. This is the outline. First, I set the context. Then I give an high-level overview of the development approach supported by CHOReVOLUTION platform. Then I provide details on CHOReVOLUTION synthesis process and CHOReVOLUTION platform. And at the end, Alexander will show you a demo of the CHOReVOLUTION Studio. So the context is service-oriented computing. And in service-oriented computing, there are two approaches to compose services. Orchestration that focuses on the centralized coordination of services by a global participant, while choreography aims at developing a distributed coordination among participants. However, reusing third-party, often black box services and composing them in a fully distributed way is a difficult task for system developers, so automatic support is needed, and here our synthesis processor comes into play. Now I'm going to give an high-level overview of the development approach that is supported inside CHOReVOLUTION platform. Choreography modelers, such as domain expert, business manager, software engineer, cooperate together to define business goals. Example of business goals are the assisting travelers from their arrival to staying and to departure. For that purpose, choreography modelers identify business tasks and the participant required to achieve the goal. Example of business tasks are reserving a taxi from a local taxi company or purchasing tickets from the train station. Once business tasks have been identified, choreography modelers specify how participants must collaborate to achieve the goal specified into choreography, and so they define the admissible flows among business tasks. This is represented through a BPM2 choreography diagram, and on the top left part of the slide there is an example of a BPM2 choreography diagram. This is the choreography diagram of one use case of CHOReVOLUTION project named Smart Mobility and Tourism. BPM2 is the standard de facto to represent choreography diagrams, and I just give some basic notion about choreography diagrams. The atomic activity of a choreography diagram is choreography task that represent the interaction between two participants by means of one or two messages exchanges. In particular, the initiating participant sends the initiating message, and then the receiving participant can respond with a message, with a return message. In BPM2 choreography diagram, there are constructs to represent parallel, alternative, and looping execution paths. We also account for service inventory that contains service published from providers that find interest in some business. So out of choreography specification and by reusing service published into the inventory, the synthesis processor automatically derives the choreography-based system that allow to reach the business goal specified by the modeler at the beginning of the process. This is the synthesis process implemented by the synthesis processor, and it is organized into several activities. And as is shown from the figure, it starts from the choreography specification, represented as a BPM2 choreography diagram. Then this choreography specification is validated against the constraint of BPM2 standard. The goal here is to check the enforceability and realizability of the choreography. Then the processor for each participant derives its participant models that contain the flows, only the flows in which that participant is involved. The next phase is the next activity is the selection, and it's about querying the service inventory in order to select concrete service that can play the role of the choreography participants. Actually, we have defined a separated process to support developers to publish service into the service inventory by defining the interface specification, the interaction protocol, quality of service, and the security. That this is the process on the left is the one, the latter one. Then in the next phases, the synthesis process generates the artifacts needed to realize the choreography. So firstly, binding components are generated. Binding components are needed when the interaction protocol of concrete service is different from SOAP, that is the choreography protocol. Then there are security filters. They are generated for those services that require security policies. Instead, adapters are needed when the interaction protocol or the interface of a concrete selected service is different from the choreography one. Finally, we have the CD generation activity. CD are coordination delegates that are responsible for the coordination of the interaction among services in order to guarantee the collaboration prescribed by the choreography specification. Now, considering the artifact just generated and the selected services, an architectural representation is generated. Then this architectural representation is translated into a choreography deployment description that is used to deploy the software artifact needed to realize the choreography. That's the overall picture of the synthesis process. Now I'll give a quick overview of the CHOReVOLUTION platform. In the front end, we have two main components that are CHOReVOLUTION Studio and the CHOReVOLUTION console. CHOReVOLUTION Studio allows to design a BPM2 choreography diagram and to define the details of the interaction among the services. And the CHOReVOLUTION Studio is an Eclipse-based IDE. Then there is a CHOReVOLUTION console that is a web application that allows to configure running service and choreography and to monitor the execution of a choreography. Regarding backend, in backend we have the generation of the concrete additional artifacts that realize the choreography. Moreover, the backend allows to deploy and configure these artifacts, and also account for the management of authentication authorization for services at runtime, and the propagation or synchronization of service to user profile from or to external resources. At execution time, CHOReVOLUTION platform provides a set of choreography instances with a different execution states and a set of virtual machines containing the service and the middleware components that realize the choreography. That was the overview of the CHOReVOLUTION platform. Now, Alexander will show you a demo of the CHOReVOLUTION Studio.
Okay, so now we see the CHOReVOLUTION Studio, how to generate the distributed system starting from this choreography. Previously, I register our provider services into the service inventory. This is the console. We can access to it. Here we can see all the provider services that are registered into the service inventory. We use these services in the system. Now, this is the CHOReVOLUTION Studio, the Eclipse environment. In the package Explorer, we can click here and to create the synthesis project. Put the name of the project, the name of the choreography that I want to realize, and select the synthesis processor that I want to use to generate the additional artifact. Okay. This is the project that we have created. We have a list of folders in which in each folder we contain all the artifacts that we have generated through the synthesis processor. Here we have the choreography. Now I delete this choreography and I provide the complete one. So when the modeler has designed this choreography, now we can start with the synthesis process by click on with the right button on the choreography, through the CHOReVOLUTION Tools menu, and click on Start Synthesis Process. Conforms to the process, the synthesis processor validates the choreography against the constraint imposed by the BPM2 choreography specification. And so, if all the checks passes, we have a set of wizard. Here we can see all the provider participants that are in the choreography, and we can select concrete services that match with the participant. So we can click here. We search all the services in the service inventory and select the correct one. So public transportation. Okay, so when all the services are binding together, participant with the concrete services, and click to the next, here we have a view where all the concrete services are non-SOAP services. For example, these services are REST services, so we need to generate the binding component. I remember you that all the additional artifacts are the SOAP services. So I click to the next. Here we can see all the services which has a security policy specified. For this example, we not have a security policy for the services that I upload to the inventory. Now can I click to next? Here we see the adaptation step in which the developer can, for example, for public transportation, can set the adaptation required by the messages defined to the choreography to the real message of the concrete service. So okay. When the developer set all the binding, all the adaptation phase, we can click on Next. Here we have other information to generate the coordination delegate. We can set the correlation task, is specific for a Beeple process. And now we can click on Finish. Here the synthesis processor takes all the information that we have set through the wizard and generate all the artifacts needed to the system that are then interposed to the concrete services that we have selected. So for example, we are binding components. The synthesis processor now generates the coordination delegate. We have the adapter already generated. Okay. Okay, the process ends by generating the architecture of the system that we have realized in the it's not fast. Okay. In this architecture, we can see all the REST services that we have selected before and the component that we have generated and how they are interposed to the services. Now, starting from this architecture, we can generate the choreography deployment description. The choreography deployment description is an XML file that contains all the services that we have selected and all the artifacts that we have generated with the URI in which an enactment engine can read this file and deploy on the cloud all the artifacts and enact the choreography by setting the dependencies between them. For example, this is an existing services. This is the URI. And for concerning the coordination delegate, we have public URI to the artifact. Now, click on the CHOReVOLUTION tools menu. We can create the choreography to perform the enact. Now I create just only the choreography on the console. Okay. Okay, here. Thanks.
So to wrap up what Alexander showed, he showed all the process I described at work on a real world use case. He covered all the phases from the definition through the choreography deployment and generation. So that's all for this talk. Try CHOReVOLUTION and by downloading the virtual machine at that URL. And if you need some more information, you can visit us at the booth number 9. Please evaluate the session if you want. Thank you. Are there some questions? Okay. Thank you.